Hello everyone. So today we are going to start with science and it's of class 7. Class 7 science and so unit number 13 or chapter number 13 you can say, which is motion and time. Good afternoon Neil. So when we are going for this chapter, every time first we discuss only about the topic. What does it mean by motion and what does it mean by time? Right. So when we talk about motion, what is it? Motion means actually when there is a kind of movement going on. A kind of movement going on means you just imagine, my drawing is not that much good. I just take an object, there is an object over here, and if this object is moving from one place to another place, from here to here, here to here, here to here, means if there is a movement and replacement and displacement, I should say displacement actually. So if we talk about motion, motion means displacement of any item, any person from one place to another place. This is known as motion. So motion means if I'm just sitting at one place and I'm studying or I'm reading a story or I'm watching TV, it cannot be called as motion because I'm not moving, I'm not displacing myself from one place to another place. I'm static to one place, whether my hands moving, my legs working, means my eyes working, I can see everything, but that is not called as motion. Motion is always displacement from one place to another place. What is time? Time, people very well. So when we talk about time, time is what? If I just asked what is the time right now, so you can say, ma'am, it's 12:05, right? So time is time. Now, what is the relationship between motion and time? So let me tell you, there is a great relationship in this chapter. You will get to know, according to the motion, the time will be decided, and according to the time the motion will be decided. Means you can say that on the basis of both the things, on the basis of both the things, that is motion and time, we are supposed to find out a number of things here. So why don't we start with something? If I just go for a race right now, okay, there is a line, you can see a line over here, and this is the finishing line. Four children are sitting, okay, four students are, you can say, the participants, right? Four runners are there, or you are there on a bicycle, whatever you enjoy to go for. So you are there, there are four students, and this is the end point you have to reach on. Now there are two things. If we are going for racing game, there are two things. One thing is who reaches to the finishing point first. Finishing point first means the distance is actually fixed here, right? The distance is fixed. Why? Because starting point and the finishing point is fixed. So the distance is fixed here, okay, and after that you have to reach to that particular place. But the matter comes, who will be the first? The person, the participant who takes the least amount of time and reaches the first, right? The distance is already decided, but who wins in the shortest time of period the person reaches, means the kind of motion the person is doing, it should be the very fast, it should be very fast, then only the person is supposed to be the first one, right? So what it was having, the distance was decided, but the winner is who reaches at the minimum time, the least time, the person who reaches to the finishing point becomes a winner. So in that one, what happened, we had to decide with the time, okay. Now you might have gone through a number of dance steps also. If we go for pop-up hip hop and all, so what we find, there are some kind of dance steps which are very fast, means few steps in few seconds, second wise the steps are changing, and your hands and body movement is too much, it's very much going on. But there are also some kind of dance steps which are very slow motion. When you go for very slow motion, even we like it also, right? So we have seen a number of dance steps too, where we have sometimes there is a slow motion dance, sometimes it is very fast going on, like break dance. When you talk about break dance, it goes very fast. So here When we talk about motion, we basically talk about the two things. And what those two things? The motion is slow or fast. The motion is slow or fast. Right. But here, as I give you an example of dance, but listen carefully. When you are dancing, are you moving from one place to another place? Are you leaving the stage and going to the outside? You are jumping from the stage and going to the staircase? No. So when you're dancing, it's only the steps which is slow or fast. But the motion is not that. Motion is from one place to another place. That is kind of motion, means when you're moving from one place to another place. Dancing can never be a kind of motion. It's just the steps which are slow or fast. So when you go to slow or fast, how can you say that something is slow or something is fast? If I give you, you might have seen some examples in the day-to-day life also. If you just check some insects, like there are nowadays, you find it's like a rainy season going on, and after that comes the winters. So you find the ants are very frequent. If cockroaches also you see, what do you observe? Ants or cockroaches, which are faster? You can easily answer that undoubtedly cockroaches are big and they are faster. They move to one place in a faster, means fast. If we talk about the ants, we find that very small. They took a lot of time, a number of steps they have to take from one place to another place. Even you might have gone for the racing also, like cycle race. You all our friends are sitting together, and then you just try to have a race, and who reaches to the point is the winner. So means in the shorter period of time, who has the much distance? Two ways we can go for. One is, as I gave you the example of this one, that distance is fixed here, distance is fixed here, and you have to reach it in the least time. Distance and least time. Okay. Second comes that if the distance is not fixed, okay, the finishing point is not fixed, but it is just told that you have to go. In that case, what happens? We have to observe in what point of time the item or the vehicle or somebody reaches from one place to another place, in what point of time. Longer distance, shortest time, and shorter distance, longest time. That only shows how much slow or the fast the item is. So when we go for the slow and fast object, you can also easily imagine that even you can observe it. If I give you an example of a plane or a two-wheeler or a four-wheeler, you can easily say undoubtedly plane is very fast, right? But when we talk about two vehicles on the road, it's very easy to identify, because when you are standing near to the roadside and somebody comes to, and a number of vehicles are moving, you can easily observe that this is the span of time, this is the area, and how the vehicles are moving. If a vehicle moves, and you can see it easily that it is moving, but sometimes you can see a vehicle is moving far and crossing everybody, overtaking and reaching to the highest. What is it? It can easily observed whether the item is slow or fast or medium, right? But on the basis of that, what happens? You just see here, I just give an example. There are two pictures actually given in your book, so you can see this picture. This is the one position given of a number of vehicles on the road, right? Second, I'm telling you, go for the second one, another picture. What it says, that which car is the fastest one. Can you ever say? I'm just sharing two pictures here. You just see here two pictures showing here. Which picture or which car you find, which device you find, means vehicle you find, is the fastest one. So undoubtedly the car or the vehicle which is crossing everybody and moving further, as has taken more distance in the shortest span of time, that's called having a high speed. So I think you people are very much frequent, and it's not a new word for you, that is speed. What is speed? Actually, speed is the same. In the shorter time period, you are covering more distance, in or the same distance you are covering in the shorter time. So whether the time is short or the distance is less depends. There is a correlation between time and distance, and then we are able to find out the speed. So how can you find out the speed of any vehicle or anything? So when we find out the speed of anything, we can easily say here. How can you find out? Actually, it is a matter of mathematics too, that if you know the distance covered by a particular vehicle or particular train or anything which covers a distance, so you have to mention the total distance covered in the total given time and how much time it had taken. For an example, if I just gave you an example of few things, like one is train, okay, one is car, one is plane. Train, car and plane. So we'll just mention is train, and this is car, and this is plane. Okay. So if I just go for these examples, the distance, let's go for, if I just say this is train and it is covering the distance of around 2000 kilometer. Okay, it is covering 2000 kilometer. Car also 2000 kilometer, and plane also 2000 kilometer. Now the matter comes how much time it is going to take. We observe that undoubtedly train is faster than the car and plane is faster than all these two, right? So here, how can we find out the speed of any particular vehicle or particular person and all? The rule is distance, total distance by or upon total time. So speed is equal to total distance by total time. And let me tell you, it's a very important formula in mathematics too, because when you're coming to class 8, 9 and onwards, and even in the competitive exam, the question comes, speed is equal to distance by time. So what is the time? If you just know very well, in 7th standard also you are having a question. If two things are given, you are able to find the third one. If any two things are given, you are able to find out the speed. If speed and distance is given, you are able to find out the time, right? And if the time is given, if the time and speed is given, you are able to find out the distance. This is the part of mathematics also. So here comes what is called a speed. So speed is actually, speed can be calculated by this formula. And what the formula is, total distance by total time is equal to speed. Whatever the time and whatever the distance covered by anything, just take the total sum of that and total sum of time, total sum of distance, and divide it by the total time, you will get the final speed. So individual, if I give you a train, as I gave you an example, the train was having 2000 kilometer, cross 2000 kilometer in 5 hours. I'm just giving an example. It is not possible, right? Or it can take 15 days. 15 days. Okay. Now you know days is days. You have to convert it into time as well. Okay. So convert the days into time means into hours. Convert the days into hours. 1 hour 24, 1 day 24 hours. So 15 days, 24 into 15. So it should always be there in time unit. We'll talk about it later. But first I'm talking about speed. So first you talk about train, the total distance and by the total time. Then you take about car, the total distance and the total time. Again, plane, the total distance and the total time. It should be divided, and finally you will get the speed of each one. Speed of each one. And how to measure the speed? You just see here, train is taking 2000 kilometer. We don't mention it kilometers, okay? 2000 kilometer. It is always kilometer, never kilometers. Remember, it's always kilometer, never kilometers. Why? Because this is called the unit of measurement. This is called the unit of distance. So whenever we go for any kind of unit, we can never say that kilometers. We cannot say minutes. Okay, we cannot say it like that. Unit is always considered as singular, so we have to take it as singular only. Kilometer, centimeter, meter, minute, second. Don't call it seconds, minutes. If we are writing, if you have the habit of it, change it, because it is wrong. It is always considered as singular. Now we are coming to the point, according to that, you can easily find out the speed of a train, car and as plane as well. So when you are able to find out the speed of all the three things, you can easily say which is the fastest one and which is the slowest one over here. Okay, so now we are coming to the point that do we have different kinds of speeds? Yes, undoubtedly we are having different kinds of speed. If you just observe, you are walking, just walking, okay, slowly, slowly, slowly. After sometimes when there is a kind of scene that you have to in a hurry, sometimes you rush also, means you run even, you walk very fast. Why it happens? When means what is it told? The speed is of two kinds. It is non-uniform and uniform motion. Means the motion or the speed can be caught, can be told as two types. Two types of speeds are there. One is non-uniform and second is uniform motion. So when we go for motion, so you just see if the speed of an object moving along a straight line keeps changing. Keeps changing means what? First, sometimes you're walking very slow, you're enjoying and walking and just looking here and there, and you're just walking very slowly. Sometimes you find, oh no, I have to be very fast. So you start running sometimes. Sometimes you walk faster. Sometimes again you are very slow. What is it? Do you find that it is similar always? No. Sometimes very slow, sometimes very fast, sometimes just fast. When it is like that, it is known as non-uniform. Means which is not uniform, which is not similar every time. So first is that kind of motion which is not similar every time. Second is the kind when we find that the speed is constant. You have to take a walk. You have to take a walk and you're just walking, walking, walking. Just your focus is to walk. It is always told that whenever we do the exercise of walking, it is always to be uniform motion. Doesn't mean that sometimes you're very slow, sometimes very fast. No. Always a uniform motion means when you're having a constant speed, never very slow nor very fast, it should be very constant, similar every time. So there are two kind of motions we got to know. Non-uniform, when it is not similar, when it is not straight, means straight line, but you're not moving in a proper way, sometimes slow speed and all, that is known as non-uniform. But when with the same constant speed you are moving, that is known as a uniform motion. So I think you can understand that uniform motion, non-uniform motion, and actually what happens, that what is the average speed. Coming to the next point, what is average speed? Average speed means what? Sometimes you walked very fast, sometimes you walked very slow, but what is your average speed? Average speed means the speed which is neither very slow nor very fast, because after walking very slow you sometimes get a feeling that I have to walk faster, but after getting very fast you feel, oh my god, I'm tired of it now, then I have to be slow, right? So average speed is what? In the particular distance, in the particular time, how much distance is covered, that is known as average speed. It is actually called the average speed, which is the average one, neither slow nor fast, average, medium you can say. And this is only known as the actual speed, because every day you cannot walk so fast or every day you cannot walk so slow. The average speed is the total comparison of that. So that is known as average speed. Now we are coming to the next point, measurement of time. So we got to know about motion. The two kinds of motions are there. When a person moves from one place to another, then only it is known as motion, and it is of two kinds, non-uniform and uniform motion. Got it? Now even we got to know the speed is actually distance by time, right? Now we are talking about time. What is time? Measurement of time. You people know very well, when I ask you what is the time right now, the best example, the best tool or instrument which is going to help you out in this regard is what? Clock, watch. Can you say nowadays that if you don't have a clock, you don't have a wristwatch, you don't have a cell phone even, are you able to find out the time? Undoubtedly, exact time is quite difficult. But yes, one thing you can say, it seems to be morning, it seems to be down, it seems to be afternoon or noon, hardly it would be 12 o'clock or 1 o'clock or 5 o'clock, it would be like that. Or it is evening, or it is night. You can easily say so, but exact time you cannot, right? If we talk about our ancestors, like it is recently introduced. So, and it is added, actually, it is added with the clock also. But the matter comes that how can we find? How could those people find? They were actually finding it through the shadow. Yeah. How much longer the shadow is and how much shorter that shadow is, it talks about it. You just see an example here. This is the sun. Okay, here is the sun. You can see that this is the sun over here, and there is a person. You people know very well. You people know very well that the sun rises always in the east, and the sun is rising in the east, and it is morning time, right? So what is observed when you see the sun? What happens this time? When the light comes here, the shadow is like this. Okay, the shadow will be like this. Shadow is longer. Okay, but when the sun comes here, the shadow is like this, shorter. Again, it is shorter, you can see. When the sun is over here, it is again coming here. Direct heat, direct light is coming over the head. And when it is coming over the head, it is not even making the shadow. And if it is making it just near to your feet only. Again, it comes here. So here you just see shadow is smaller. Here it comes, shadow is bigger. So easily you can say how much big the shadow is, that much long the day has passed. If it starts from the morning, the shadow is bigger, bigger, bigger. Initially it is bigger, and from bigger it becomes shorter, shorter, shorter. And when there is no shadow and the smallest shadow, it is the afternoon. It is the noon here. After that, after the noon comes afternoon. Okay, it comes afternoon. So now again the shadow will start being longer, 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 and longer. And there comes a time when it is dark. There is no sun, so no shadow also. So we can easily imagine that how our ancestors were finding out about the time. Even it was not there. More other instruments the people had. And what it was? It was sand clock. I think you might have seen sand clock. Sand clock is actually here. Let me show you the sand clock. Oh, it must be here actually. If I have seen, yeah, this is called the sand clock. If you just see, go for this or these three. So these are actually the things which were used by our ancestors in earlier time. You just see there is water. Okay, this is water, and how is it telling you? When the shadow is like this, when it is directly coming over here, and when it is coming over here, it is showing a great distance. Because of that, we are able to find out the daytime. Now here, the sand clock is also mean for it. It is talking about the second, second, and second. You can also find that sometimes the clock, the sand clock, is only talking about the 12 hours distance. When 12 hours got over, you have to tops it turn, means ups down, and then again it will go for again next 12 hours. So sometimes it shows for 12 hours, sometimes it shows for 24 hours as well. This is the thing, okay, which is, this one is about shadow. Okay, the first one is about the shadow, and it talks about the density over here. Second, we talk about the clock. And the third one is actually what? It is a figure over here, and it is what of Jantar Mantar. So this is a sundial. How can you say the sundial? Actually, how is it helping you out to find it? This you can imagine as a person. This you can imagine as a person. And the stairs which have been used here, you can easily see the staircases. Where does the shadow reach? If the sun is here, the shadow will come here. Sun come closer, the shadow is here. Sun come up, the shadow is here. There comes a side, there is no shadow even. So what it talks about? On the whichever the step the shadow reaches, it actually talks about the time. That's only the sundial at Jantar Mantar. You can imagine just through this building or this particular structure, the entire sundial was made, and the people were able to use the able to get the time. So here we have that the time when we didn't have the clock, we didn't have the wristwatches, we didn't have the phone. These things were actually used by our ancestors. Okay. Now the matter comes that as we were going through that measurement of time, okay, we were going through measurement of time. So one thing we got to know that our ancestors were doing like this. You have nowadays digital clock, wall clock or table clock, all that we have. How can we say and what is the unit of it? So before going to find out the unit of it, we'll go for one thing. And what is it? We'll go for pendulum. What is that pendulum? Let me tell you, this is called the pendulum here. If you can see this one, a kind of dial which is moving here to there, here to there. Even, when somebody was to hypnotize somebody and just telling you people, it's just like a pendulum. Okay. So when you go for pendulum, it's a kind of periodic motion. We are having like some periodic motions are there, some non-periodic motions are there. So how can we identify what is what? Okay. So we are coming to this part now here. Here there is an example and I'll let you know few terms used here. The terms must be bob, the terms must be bob, the terms must be oscillatory motion, and the terms must be oscillation. Bob, it's bob, oscillatory motion and oscillation. Now we'll go for all these three things here. Okay. Now here we come to know that what is oscillatory motion. So first we'll talk about this one. You can see here that there is a metallic ball. Okay, there is a metallic ball and it is hanged over with the help of a string. Okay, with a thread or with a string. Here you can find this is the metallic ball with a stand or with a strain over here with a thread it is attached through the wall. So you can say a ball over here, a ball is attached to it. This ball is actually known as bob. Okay, this ball is known as bob. Now we'll go for the kind of motion. So what kind of motion? Here we are talking about oscillatory motion. So what happens in this one? You just take one point here. Okay, the ball is here, it will go there, then come back there, and again it will come back to its place. It will go back and again. Means any of the movement when it reaches to its place back. Let's see one more. If it is here, it goes there and it comes back here. So when it comes back here, this is called oscillatory motion. Means from the point it had started. For an example, take this one. It started from here, went there and came back. Went there and came back. So what is it actually? It is known as oscillatory motion. The point it started from, after movement along, it reaches to the same point of place. When it reaches to the same point of place, same point, that is known as oscillatory motion. Now we are coming to know that what is called oscillation. So we got to know oscillatory motion, we got to know about bob. So don't forget that when we talk about oscillatory motion, started from a point and coming back to the point, that point only. Started from O, coming back anywhere it is going A or B or C or D, but it is coming back to O. Then only it is known as oscillatory motion. When we are there, means when to and fro, and that is known as oscillatory motion. Now the matter comes, what is oscillation? So when we go for oscillation, we find it is completed one oscillation. It is completed one oscillation when it starts from a point O, goes there to A, comes back to B and comes back here to O. When it started from there and comes back comes back directly to it, then it is known as one oscillation. So whenever we go for this, started, it is the point, done and done. When it is coming here back, it is called one oscillation. Means you can count the number of oscillation, how many times it is doing the movement, how many times it is doing the oscillatory motion. That is known as oscillation. Means it can be counted as in number. But do remember, one oscillation means starting point, started and went and came back over there only. It doesn't mean that it started from A and reached to B, then it is known as one oscillation. Never. Started from A, reached to B, again it came back to A, then only we call it one oscillation. Coming to the next point here, another point is also given here, that is what is that time period. Time period means you are able to find out how much time it is taking for one oscillation. Now you may have a query, don't you think that it is very difficult to find out, means the dial takes only this much time, and are you people able to find out the time period of it? Very difficult. So why don't you do one thing, you have to start with a stopwatch. Okay, if you have, nowadays everybody is having a stopwatch in your actually phone, but as you're the students, you don't have a phone, doesn't matter at all. So what you need to do, you just observe, start observing it. What you have to do, take a metal ball, started with a string or a thread, hang it over, to a place, not in your hand. Remember, not in your hand. Just tie it with somebody, somewhere where it can move freely. Let it stop first. When it stops, just push it once. Just push it to one side, either the left hand side or the right hand side. Okay, just a movement. You're not supposed to push it. Okay, very slow motion. You just leave it. You find it started from there, and you have to just counting. Okay, one time it went there and came back here. Two, went, came back here. Two, 3, 4, 5, 6. Let it go for 20 times. Okay, and in 20 times, how much time it is taking? While going for 20 oscillation, how much time it is taking? You can go for it, right? So when you observe, you just imagine that for 20 oscillation, it has taken around 10 minutes. Though it will not take, you people know very well. Just imagine it will take 10 minutes. Okay, when it takes 10 minutes over here, then you have to check with the time. How many times it did? 20 times. 20 times oscillation it did. 20 times oscillation it did. And how much time it took? It took 10 minutes. So in one oscillation, how much time it takes? Very nice, very easy to say. 20 times in 10 minutes. So how to find out? 10 divided by 20. So we'll find it 1 by half. 1 by 2 means it's taking 0.5 minute. Means 0.5 minutes is what? 0.5 minute is what? 30 seconds. 1 minute 60 seconds. So half minute means 30 seconds. So it is difficult to just check with the time. This is the stopwatch and how much time it takes in one oscillation. Don't need to go for it. You can take the stopwatch, take it for 20 times, 30 times or 40 times. You just count the number of timing, that how many times it is oscillating. Now by that time only you start counting. Start the time and start counting, and after that you divide it. When you divide it, you will easily get for 1. It's very difficult to find for many, so it is okay now to go for 1. So this way you can go for the time period of it also. You are able to find it out, the time period. And last we are going for it's the units of time and speed. So when we talk about units of time, I think everybody knows very well. Units of time are second, minute and hour. It depends second, minute and hour. Okay, even we are having a certain interval of time that is known as day, month and year as well, right? So basically we are talking about the units of time over here. So we are basically talking about the basic unit of time is second. Basic unit of time is second. Its a larger unit is minute. The symbol is MIN, not MINS. Next is hours, that is H. H denotes hours, MIN denotes minutes, and SEC or S denotes the second. This is the unit of time. Now, what is the unit of speed? How can we find? So, distance in kilometer, right? And time in hour. And this is the speed. So, what is the unit of speed? Kilometer per hour. Kilometer per hour or minute per second. meter per second, meter per second, kilometer per hour. So what is the distance? First is the distance over here, means the unit of distance given over here. Second is the unit of time given over here. And this is called the unit of speed. Unit of speed is equal to unit of distance by unit of time. Unit of distance by unit of time, that is known as the unit of speed. So for now we can end up the session and you can understand how many things we talked about. So you should always remember the timing, the symbols and all that. And it should always be, as I told, that it should always be singular, never plural. If we say 50 kilometer, it is correct. But if we say 50 kilometers, it is incorrect. 80 centimeter, 8 centimeters correct, but 8 centimeters is completely incorrect. So if we go for all the units, so you got to know a number of things today: slow and fast speed. Then you found that what is the motion and how many types of motions are there, non-uniform and uniform motion. Then you got to know about what is speed and how can we evaluate, how can we find it out. Along with that, you found that what are the speed, means what are the units of time and speed. I think for today it is quite enough for you people. Rest will go for the next time, means directly today or tomorrow only. And finally we'll be ending up the session. Okay, thank you so much. Just give a thumb. And if you like the session, if you have any doubt, you can ask me as well. If you have no doubt, you can leave the class. Thank you so much.